see a lot of people getting wrongly E minus J omega T. Alright, which cannot be like that. Now, the standard notation is like this. Ej omega T E minus J K Z Ej phi. Okay, this is the standard notations, or in instantaneous form is cosine omega T minus Kz plus phi. In here, it means that the propagations is in the plus z directions. Plus z directions. Alright? And the propagation vector k, in this case here, is 6 a z. Alright? There are still a lot of people make these mistakes, alright? This is minus here, propagation is plus. This is plus. Okay, there are still quite a few people say that the propagation is in a minus x direction. It's wrong. Okay, so when it is like this, cosine omega t plus 6z plus 5. This one, the k is equal to minus 6 az. If this is plus, this is minus. Okay? And you must have it as omega t as plus. Omega t as plus. Omega t as minus, it is wrong. Okay? You cannot have omega t minus. Alright, let's go through the last class test and we'll see. Okay, question 1. The instantaneous form of an electric field is E naught cosine omega t 6x minus 6x plus 5y. Cosine omega t minus 6x plus 5y plus 0.4. Okay, so this one becomes Ej omega t E minus J 6x minus 5y Ej 0.4. Okay. Small mistakes are those people who copy this one down, this one still plus. That is called small mistake. But small mistake is still counts. Okay, those 1 mark deducted, you don't get full marks already. Alright, so don't do that. Okay, make sure that you copy correctly. This is minus, this is minus, then it becomes plus. Alright? So don't commit any careless error. Okay, so this one, the k, the propagation vector is 6 ax minus 5 ay. Okay, there are people who write which is equal to k equal to 6x ax minus 5y ay, which is also wrong. Alright, which is also wrong. K is not equal to 6x ax minus 5y ay. This is k dot r. Give you 6x plus 5y. Okay, because k is this and r is equal to x ax plus y ay plus z az. Alright, gentlemen, please pay attention, alright? Okay? So this is basically k dot r if you do this. Alright? So k is this and not this. Okay, this is another error that people commit. Alright? So remember, this one must be positive. Omega t must be positive. Alright? The second one, E naught cosine 6x minus omega t plus 0.4 plus 5y. You can't write it as ej6x minus j omega t ej 0.4 ej5y, which is wrong, okay, because omega t cannot be negative. Alright, cannot be negative. So when you do that, you must make sure that in the cosine term, the omega t must be positive. So what you should do is in fact make use of this simple formula. Cosine theta equal to cosine minus theta. Alright, so you rewrite. This one become cosine minus 6x plus omega t minus 0.4 minus 5y. And once you rewrite that, omega become positive, then it is correct to say that it is e minus j 6x, ej omega t, e minus j 0.4, e minus j 5y. Okay, now your k is equal to, remember k, you must have a minus in front first, then you can k dot r. So this minus sign must be outside. So if this minus sign outside, you have 6x plus 5y. So k is equal to 6ax plus 5ay. Alright? So k equal to 6ax plus 5ay. Remember, the omega t must be positive, cannot have negative. The next one, sine. Okay, you cannot have sine also. The standard form is cosine, so you cannot have sine. Sine omega t minus 6x plus 0.4. Now, there are two ways to do it. If you are familiar with your trigonometry, sine theta equal to cosine theta minus pi by 2. Okay, if you are not familiar, at least you should know that sine theta is equal to cosine pi by 2 minus theta. You must at least know this one. Alright? If that is the case, because you want to convert it to cosine, okay, convert it to cosine first. So this one become cosine pi by 2 minus omega t minus 6x plus 0.4, which is cosine pi by 2 minus omega t plus 6x minus 0.4. Right. But once again, this one minus here is cannot. You cannot have sine, you cannot have negative here. So you put now you have cosine theta equal to minus cosine theta, become cosine minus pi by 2 plus omega t minus 6x plus 0.4, and now you are home. Okay, so it is ej pi by 2, ej omega t, e minus j 6x, ej 0.4. So now the propagation is k is equal to plus 6ax. Okay, remember this minus, this plus. Alright? So basically, remember, alright, the standard term is cosine and omega t must be positive. Omega t must be positive. And the third thing is that for the k, for the propagation vector, there must be a minus here. So the standard form is always ej omega t e minus j k z. Minus plus. You must follow these two conventions. Alright? Must follow these two conventions. Now, question 5 is actually a trick question, but it doesn't matter. Quite a few of you can got it correctly. Okay, it is not an issue. Oh, sorry, question 5 is a trick question. Question 4 is not. So it is sine 6x minus omega t plus 0.4. Okay, this is also very simple. Remember, if you cannot, you don't know how to use this formula. Okay, you don't know how to use this formula. Doesn't matter. The basic formula you must know is sine theta equal to cosine pi minus 4 minus theta, and cosine theta equal to cosine minus theta. These two basic formula will get you everywhere. Okay, so this one becomes cosine pi by 2 minus 6x minus omega t plus 0.4. And of course, when you write all these things, when you copy, don't make mistakes. Okay, there are several people who copy from this line to the next line, copy wrongly. Alright, don't do that kind of mistake. So this is cosine pi by 2 minus 6x plus omega t minus 0.4. Okay, you got a cosine, you got a plus omega t, you are home. Alright? So now it is e j pi by 2, e minus j 6x, e j omega t, e minus j 0.4. So once again, k is equal to 6ax plus 6ax. Alright? Now, this one can be plus, no problem. Okay? If this one end up to be plus, it is alright. Then this is plus. Omega, j omega must be plus. Okay? But this one end up plus, what does it mean? It means that the propagation is minus 6ax. That's all. Alright? So this one can have plus, can have minus. Okay? But this or j omega t must be plus. Okay? If this is minus, propagation in a positive direction. It's a positive, propagation in a negative direction. Alright? Finally, this one, as I say, is a slight trick questions. Alright? But you know, many of you got it right, so it's not a big trick at all. The trick is actually j means that, what does it j mean? J is equal to e to the power j pi by 2. That is what it is. Okay, j is just equal to e to the power j pi by 2. So in fact, you have a j sine omega t minus 6x. So it is e j pi by 2. Don't convert first. It is j cosine pi by 2 minus omega t plus minus 6x is j cosine pi by 2 minus omega t plus 6x is j cosine pi minus pi by 2 plus omega t minus 6x. You see that from here to here I apply sine theta equal to cosine pi by 2 minus theta. This one I just expand it out. From here to here I just write cosine theta is equal to cosine minus theta. Okay, then from here I can write e j pi by 2, e j minus j pi by 2, e j omega t, e minus j 6x. Okay, so finally the propagation factor is still equal to plus 6ax. Okay, so no big deal. Alright. Remember, once again, the cosine omega t must be there. Omega t must be positive always. Okay? The k, if there's a negative here, is propagating in a positive direction. If the positive here is propagating in the negative direction. That's about all. And then you don't include the x, you just the number. Alright? Okay. So what I'll do is, we are going to do tutorial 5 first. Okay, we are going to do tutorial 5. Make sure that the memory is still fresh. Alright. The electric field of a plane wave in free space is given by this. ext is equal to y 50 cosine 10 to the power of 8t plus kx. Now, with this one here, directions of the wave propagations. What is the directions of the wave propagations? What is the directions of the wave propagations? Can somebody tell me what is the direction of the wave is propagating? The wave is propagating in the minus x directions. Alright? The wave is propagating in the minus x direction. Remember, cosine omega t minus kx means that in a plus x direction. If this is minus, propagating in the plus x direction, it is plus, propagating in the minus x direction. Alright? Calculate the wave number k and the time t1 required for the wave to travel a distance of lambda by 2. Time is equal to, or speed is equal to distance divided by time. So time is equal to distance divided by speed, right? Okay, so we need to find the speed of propagations when the distance is equal to lambda by 2. And we have to find the wave number. What is the wave number? The wave number is k here, that we do not know. Okay? If we do not know what is the value of k over here. How to find the value of k? You have the equations. K is equal to omega square root of mu epsilon. Okay, k equal to omega square root of mu epsilon. Now, what is omega? Omega is here 10 to the power of 8. What is square root of mu epsilon? Since it is free space, it is mu naught epsilon naught. And what is square root of mu naught epsilon naught? It is equal to 3 times 10 to the power of 8. This one I don't have to find out. Ladies and gentlemen, if every time you go and you got to go press a calculator for this one, you are in trouble, alright? Because the velocity of light c is equal to 1 over square root of mu naught epsilon naught is equal to 3 times 10 to the power of 8. So save you a lot of time pressing the calculator. Okay, so 10 to the power of 8 divided 3 times 10 to the power of 8 is equal to 0.33. Alright? And then what is the time? T is equal to distance divided by velocity. The velocity is 3 times 10 to the power of 8. What is the distance? The distance is lambda by 2. The distance is equal to lambda by 2. Now, k is equal to 2 pi over lambda. So lambda is equal to 2 pi divided by 0.33. So you have the lambda by 2 here. Correct? Yeah. But actually I can even don't calculate this one. If you want, I don't have to calculate this one. Now this is C. It is equal to half of lambda over c. What is half of lambda over c? Do you know the other equations? C is equal to f lambda. Do you remember this one? So lambda over c is equal to 1 over f. So this is equal to half of 10 to the power of 8 divided by 2 pi. Because 10 to the power of 8 is omega. So f is equal to omega divided by 2 pi. So you see there are a lot of ways to do. You know, this few formula, I keep on saying, this few formula you must know. You can put it in the cheat sheet, but remember you must have lot of practice, okay, on how to do all this thing, which is equal to 2 pi over lambda. V is equal to f lambda. Alright, and what else? That's all. Okay, which is equal to 1 over square root of mu epsilon. Now this, we just keep on practicing. Okay, one more time, alright. Directions of propagations, since this is plus, the direction of propagation is in a minus direction. If this is plus, this is minus. But you must make sure that this is omega t is a positive. If there's a trick question, say that if the trick question is like this, if the trick question come out like this, then this is wrong. Okay, then you must convert it into cosine 10 to the power of 8 t minus kx by using cosine theta equal to minus cosine minus theta, and then the propagation is a plus x direction. Okay, so remember the omega t must be always positive in a cosine term. Alright, so if this is plus, propagation is in the negative directions. Wave number, very simple, wave number k equal to omega square root of mu epsilon, and omega is given here 10 to the power of 8. Square root of mu epsilon, well, free space, mu equal to mu naught, epsilon equals epsilon naught. You do your calculator, or you know this, just substitute in and there you go. Okay. Alright, and then the time, well, time is equal to distance divided by velocity. Okay, distance is lambda by 2, k is equal to 2 pi over lambda, so you can find lambda and sub in here, and c is 3 times 10 to the power 8, sub in here. Or you know how to manipulate the equations, c equal to f lambda, so you just sub in here, you so get it, you can save the steps of finding lambda. So, whatever. Alright? The next one is, sketch. Okay, sketch, I can't sketch. I can't sketch, honestly. When I was in school, where is this one? Solutions. Where's the sketch? Oh, not sketch, or sketch on the next page. Okay, now, okay, so at t equal to 0, t equal to t by 4, and t equal to t by 2, and all this, so you just sub it in and sketch. And as I said, I can't sketch because when I was in school, my art is always 49, 50 marks. Okay, so this is how you sketch. Where t equal to 0, t equal to t by 4. You have the solutions, right? Now, and t equal to t by 2. Now, why is all this dot joining by the line? Okay, why is all this dot joining by the line? It shows you that wave is actually propagating in the minus x direction. You can see that this point is here, at this time is here, and at that time is propagating backward in the minus x directions. Alright? Okay, question 2. If you do not know anything, please stop me, alright? Please stop me and ask me to repeat or clarify. Alright, don't just let me go blah 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 and then after that you find you have problems. Okay? Ladies and gentlemen, especially those of you who are playing with your handphone. Okay? I mean, you come here and don't play with your headphones. I mean, there are some important messages can always reply after class. Okay, if you have uniform plane wave propagating in a dielectric non-magnetic medium, okay, non-magnetic medium but it's a dielectric, so that means there is the epsilon r. Okay, you look at the keywords. Okay, just like primary school exams, you look for keywords. Okay, dielectrics. Okay, in a medium. Now ET, ZT is equal to x to cosine 10 to the power of 8 t minus z over square root 3. Determine the frequency and wavelength of the wave. Well, it's so simple. Okay, omega is equal to 2 pi f is equal to 10 to the power of 8. So frequency f is 10 to the power of 8 divided by 2 pi. Wavelength. Or what is the wavelength? Remember, now there is a dielectric of epsilon r. The speed of the wave propagation is not the speed of light. It's not 3 times 10 to the power of 8. So lambda is not equal to c divided by f, which is not correct now. Okay, because the velocity is not c. Now, if the not c is what? I don't know epsilon r. I don't know epsilon r, so how to find c? I know v is equal to 1 over square root of mu epsilon. Mu is mu naught, epsilon r. I do not know epsilon r, so how to do it? But remember, we can't run away from these few equations. And you know K. The directions of propagation is in the plus z direction because this is minus, so this is plus. And you know K. K is equal to 1 over square root 3. K is equal to 1 over square root 3. So 1 over square root 3 is equal to 10 to the power of 8 square root of mu naught epsilon r. So there are many options for you to do now. You can find epsilon r here because mu naught epsilon naught, you know, you can find epsilon r here. Or you can transport everything to v is equal to 1 over square root of mu naught epsilon r is equal to 10 to the power of 8 times square root 3. That's all. I mean, if the question don't ask to find epsilon r, I don't even want to find epsilon r. Oh, it does, the next one. Okay. So, I can have the velocity, and I can have a velocity. Once I have the velocity, this is equal to v over f. Alright? So, again, remember, there are only very few equations. Very few equations for you to work on. This is one of them. V equal to f lambda is one of them. And the derivative, the consequence of these two equations, you get lambda equal to lambda naught divided by square root of epsilon r. V is equal to c divided by square root of epsilon r. Now these two equations, the two circle equations, are actually the consequence of the two above. Okay, because of epsilon r. Alright? These two are the basic, these two are actually derivative from that. Okay, the next one is dielectric constant. Now, dielectric constant is here, right? Dielectric constant is here. Mu naught is given. Mu naught is known 4 pi times 10 to the power minus 7. Epsilon naught is 1 over 36 pi times 10 to the power minus 9. Epsilon I can be found. Okay, or if you want, you can write it this way. Then epsilon I is found. You don't even need mu naught and epsilon. Mu naught and epsilon naught. Because remember, 1 over square root of mu naught epsilon naught is equal to 3 times 10 to the power 8. Alright? Find the expression for the corresponding instantaneous HQ. Okay, sorry. Any questions before I proceed? Is it okay? Any questions? Any questions over there? Any questions? Anything need to clarify? No.
We're just very confused about how you actually get the 10 to the power of 8 root epsilon r over
10 to the power of 8 is here.
No, I mean the
This one.
yeah, how did the
This is K. K is 1 over square root 3.
yeah.
This one. This is omega. Omega is 10 to the power of 8. Is given. And this is just a formula. From here. Until here, is it alright?
Yeah.
Okay. Oh, mean this part.
Yes, correct.
Okay. Because this one. C is equal to 3 times 10 to the power of 8. It's equal to 1 over square root of mu naught epsilon naught. So I just plug that in. I just plug that in. Same thing that I did previously. Alright, any other questions? Okay, if not, then find the instantaneous form for H. Okay, instantaneous form for H. Now, remember, although I have quick way of going directly from instantaneous form to the instantaneous form, but I don't want to confuse you. I think we do the standard procedures. Alright, we do the standard procedure. So the phasor is equal to x2 ej omega t, which is understood. Okay, or in this case here, E j 10 to the power 8 t. Alright, E minus j z over square root 3. Alright, so this is instantaneous form to phasor form. Alright, then what is H? H is equal to 1 over zeta. This is not zeta naught, okay, because this is not free space. So 1 over zeta, and what else? E cross K or K cross E? E H K. E H. So H, K cross E give you H. E cross H give you K. H cross K give you E. Alright, so this is K cross E. Now, what is zeta? Zeta is equal to square root of mu over epsilon, which is equal to mu naught epsilon r. Alright? Okay? Epsilon r you have found. You say, in all these procedures, I can even never make use of mu naught epsilon naught at all. So this is equal to 120 pi divided by square root of epsilon r. Why? Because mu naught epsilon naught is equal to 120 pi. So I just plug them in, I just got it. Alright? So, there you go. So, I have this one here, but where is my k? My k is the positive AZ directions. Okay, so this is 1 over zeta. K is positive AZ direction, so this is z. Not square root 3z, alright? This is the unit vector of k. So the unit vector of k is z. The magnitude of k is 1 over square root. Alright, the magnitude of k is 1 over square root 3. Magnitude of k is 1 over square root 3. But the unit vector of k is in a z directions. So cross x 2 ej 10 to the power 8 t e minus j z square root 3 is equal to 1 over zeta. Zeta is calculated from there already. Z cross x, give me what? X, Y, Z, Z, X, Y. Correct or not? So positive Y. 2 E J 10 to the power T E minus J Z square root 3. Alright, if that's the case, my H ZT is equal to Y 2 over zeta cosine 10 to the power 8t minus z over square root 3. Okay, one final check. One final check is that for lossless propagations, this and this must be exactly the same. Okay, that's why I say I can do a fast way, because I know that the cosine term must be exactly the same. Alright, so this is doing just a quick check. Alright, any questions? Any questions? Once again, alright, if you find that there's something unclear, put up your hand and ask questions, alright? There's nothing wrong in asking questions, nothing wrong in stopping me, nothing wrong in asking me to repeat again, alright? Alright, can I proceed? Question 3, question 4, oh, okay, two more questions to go. Well, I'm sorry about this one, because you see, as I said, my printer is made in China. So the operating systems somehow automatically convert a lot of Chinese symbol into Chinese words. I do not know what the heck it's all about. But too bad, you know. Because the Microsoft Words is tied to your printer somehow. You know, it's tied to your printer somehow. I don't know why it's like that.
Bro, maybe you can save to PDF first, then you print. Save to PDF first.
But this one I saved to PDF already.
Then it happen.
I don't know, because it just converts just automatically like this. I don't know. That one is honestly not beyond my expertise, so I don't bother. Alright, 60 megahertz plane wave. 60 megahertz plane wave. That means F is equal to 60 times 10 to the power 6. Omega is equal to 60 times 10 to the power 6 2 pi times 2 pi. Okay, so I have omega. Traveling in the minus x directions. Traveling in the minus x direction. I get the minus x directions. So my K is in a minus x direction. The second thing I know. In dry soil, relative permittivity epsilon r equal to 4. Okay. And we like to give this kind of number because you remember a lot of square root of epsilon r. So square root of 4 is equal to 2. Okay, so we make life easier. Relative permeability mu r equal to 1. Good. As an electric field polarized in the z directions. So that means your E, okay, propagation is x, t, polarized in the z direction. You see this one here, I write xt to signify that I'm propagating in the x. I don't know plus x or minus x, but there's something to do with x and to do with time. So this is my time domain kind of thing. Okay, polarization in the z direction. Assuming dry soil to be approximately lossless and given that the magnetic field has a peak. Oh boy, magnetic field now. Okay, so magnetic field has a peak. H has the maximum equal to 10 milliampere per meter, and that its value was measured to be 7. Then H, this is max, equal to 7 milliampere per meter at t equal to 0. And x equal to minus 0.75. X equal to minus 0.75. Develop complete expression for the wave, electric field, and magnetic field. Well, seems to be how to start. Okay, seems to be the questions of how to start. Now, electric field and magnetic field, remember, they are polarizations. Sorry. What is their polarization? This is electric field. Okay, electric field polarized in the z direction. What is magnetic field polarizations? What should it be? What? This is z. This is z. X, Y, Z. X, Y, Z. Okay, your electric field is in the z directions. If where is my k? My k is in the minus x directions. So how? What should my h should be? Where should my h should be? Very simple. Okay, if you can't do that, you remember E is equal to or H is equal to, come back here, K cross E. Come back to here. Okay, use this one. Use this one. What you now require is only the polarization. So K is equal to minus X. Alright? Cross E is what? Z. Okay? So, Z minus X cross Z. How to get minus X cross Z? It is equal to Z cross X. Remember, your minus A cross B is equal to B cross A. Alright? So if that's the case, this is equal to Z cross X. If Z cross X give you Y, so you are correct. Alright? So the polarizations of the magnetic field straight away can be ascertained if we go back to this particular formula. Remember, there are two formulas here. One is E is equal to zeta H cross K, and another one is this one. H is equal to 1 over zeta K cross E. These two formulas you must know as well. So K is equal to minus X directions, K is equal to minus X directions, and E is polarizing in the Z directions. E is polarizing in the Z directions. So it is minus X cross Z. But how to get minus X cross Z? Minus X cross Z, how to do? It's actually minus X cross Z is equal to Z cross X. And Z cross X give you Y. Alright, so this is Y. Okay, so now I have a magnitude H naught. I do not know what it's all about. I do not know what it's all about. You must have a cosine omega t. Okay, and what is omega? Omega t is known. This is 120 pi times 10 to the power 6 from here. Omega is 120 pi times 6 t to here. And what it is? Propagating in the minus x directions. Okay, electric field propagating in the minus x direction. Magnetic field must also be propagating in the minus x direction. Same. So it's plus, don't know what is a K yet, K X. Alright, so we agree have the magnetic field expressions already. The only thing that we do not know now is K or H naught. Right? But this is not concrete yet, right? This is not concrete yet. The concrete one is there's still a certain phase angle phi. Right? There's still a certain phase angle phi that needs to be evaluated. Okay. Now, sometimes phi can be turned out to be 0. Okay, if you find that the question is such that there's no way that you can determine phi, then you quickly drop the phi and assume that it is equal to 0. Okay? Now, so now what do we know? What do we know? Anything? What do we know from here? We do not know H naught, we do not know K, we do not know phi. But really K, do we do not know K? I think K, we know K. K is equal to omega square root of mu epsilon. Okay? Omega we know, which is 120 pi times 10 to the power 6. And this one we know. This is equal to mu naught, epsilon naught, and epsilon I equal to 4. So K we do know. Okay, so K we do know. K we know now. Okay, K we know now. Now, what is the next thing? The next thing is that the maximum magnetic field is 10 milliampere per meter. Okay, so what is the maximum down here? Of course it's H naught, right? Because cosine term, the maximum value of cosine is equal to 1. Correct or not? Because maximum of cosine is equal to 1. So this is the maximum. This is 10 times 10 to the power minus 3 milliampere. Alright, milliampere. So 10 times 10 to the power minus 3. Alright. So then it say that the value is equal to 7 and t equal to 0 and x equal to 0.5. So what does it mean? It means that 7 milliampere per meter is equal to 10 times 10 to the power minus 3 cosine 120 pi times 10 to the power 6 times 0 times t equal to 0 plus k is already calculated from here, and x equal to minus 0.75. Minus 0.75 plus 5. You can calculate 5. Now you can see that you can calculate 5. This is equal to 0. This one you know, so you can calculate 5. Right. If there is no this information, this piece of information is not given here, you quickly drop on 5 because then 5 cannot be calculated. Okay, but because of that particular piece of information, then okay, so now you got to complete this one already. Then from there, you go down to electric field. Okay, electric field, I already know that this is here already. In fact, the important thing is this one. Because what? Because the rest are the same, right? Remember we say that the rest is the cosine term must be exactly the same for lossless media. The cosine term must be exactly the same for lossless media. Polarization is already known. What is the magnitude? Come on. The magnitude is always E naught H naught is equal to zeta. Or E over H is equal to zeta. So, or H is equal to E over, so I want to find E, sorry. So E is equal to zeta H. Alright, E is equal to zeta H. So now this, the magnitude is equal to 10 times 10 to the power of 3 times 10 to, 10 times 10 to the power of 3 times zeta. So this is the complete electric field. And what is zeta? And what is zeta? Zeta is equal to square root of mu naught over epsilon naught epsilon r is equal to 120 pi divided by 2 equals 16 pi. Now, at this point here, I have one question here. Alright, I have one question here. Which way you can follow better? This way, or you want me to go through the solutions, look at the solutions as the standard solution, and then we just go line by line. This way. Okay. Because sometimes some people think that, because they have something that can go back to and write note, according to the standard solution. There are people who like that one. Okay, depending on how you want. That's what I'm going to ask you. Okay, so there you go. Any questions? Any questions? Any questions? No? We move down to question 4. Or do you need some time to digest it? Okay, yeah? By the way, for those of you who comes in late, alright, for those of you who comes in late, there is a, you can go and check the script afterward at E4, at E40706. Okay, you can check the script for CA1 at 5:50 p.m. at E40706. Alright. And for this CA1, I'm set to say that for this CA1, our class didn't do that well. okay, our class didn't do that well. In fact, the average mark for this class, okay, is 55, and for average mark for the other 3 classes are all around 65. So you are 10 marks below the other 3 classes. Okay, so we have to work harder. Okay, I don't know why. Somehow I don't know whether you are complacent or complacent or whatever. We have to work harder. And that's the reason why I have decided to add another 3 remedial classes. Not starting tomorrow, but starting next Saturday. Okay, all the 3 Saturday. Now, it's not compulsory for you to come. I will be marking attendance. But please do come if you have any issues, any problem that you need to clarify, especially those on electric field and magnetic field. Alright, these slides are already mounted in IBLE already just now. Alright, and when coming near to exams, okay, these are the office hour. Okay, these are the office hour I leave open. That means I'm not teaching and I do not have any meetings, appointment. I'll be in my office. Okay, but you are not the only class. Okay, I'm teaching all these classes. Okay, 201, 304, 401, and TEE. Okay, so first come, first serve. Okay, you come in, first come, first serve. Except this day that 4th of December, you have your exam 5 p.m. If you have any last minute questions, please come along. As I said, this one is on IBLE already uploaded already, so there's no need to take pictures. All right. Okay, so we have to work harder. Okay, because 10 marks is really big gaps. Okay, the other class at the end of it when they draw the bell curve. Okay, when they draw the bell curve, the other class will be centering at B, and you will be centering at C. Okay, it's not centering at C. That means there will be a tail end of D and tail. Okay, which is no good. All right, so we have to push our average higher. All right. Work harder. All right. We all have to work harder. Okay, last questions. An electromagnetic wave with the following instantaneous expressions. So my T is equal to 1 over square root 2 AY plus Z. Now this is a polarization. Alright? Alright, gentlemen, let's come back. Okay, I mean, no need to cry over spilled milk. Okay, the result is already done, it's done, so we look forward to the next CA and exams, alright? So AY plus Z, so this is the polarizations. This is the magnitude. This is the magnitude, this is the polarization. And this is the standard R problem, right? Okay. Cosine beta square root 2 y plus z minus omega t. That should not be like this. Okay? But this is easy because this is cosine, this is not sine. And since omega t is minus, so we use the cosine theta equal to cosine minus theta. We change it back to omega t minus beta square root 2 y plus z. Okay, we change it back to this one. Alright, remember omega t must be plus. Alright, and from here, what is my directions of propagations? There is a minus sign here, there's a yz here, minus sign here, yz here. That means my directions of propagations k is equal to x plus y, or no, I Okay, we write this k is equal to beta over square root 2x. Sorry, where's the x? I'm bad. Okay, y plus beta over square root 2z. Okay, now because this one I can write as minus beta over square root 2y plus beta over square root 2z. I just multiply it in. Okay, I just multiply the beta over square root 2 in. Alright, if I multiply by beta over square root 2 in, this is what I get. And since this is minus sign, there's a minus here, this is plus plus. Now, in case that this is minus, in case that this is minus, then this one becomes minus. And if this is plus, if it's like this, then this is minus plus. Alright, so you got to be careful of the signage, alright, the sign. Okay, I have K. Alright, so the electric field is almost complete now. I have magnitude, I have polarizations, I have omega t, I have propagations. Okay, so the propagation factor determine the XYZ component of the wave number. Okay, this is the wave number. Propagation constant is also called wave number. So the x and y exact directions, the x direction is of course 0. So kx is equal to 0. Ky is equal to beta over square root 2. Kz is equal to beta over square root 2. No problem. Okay, so this one is fast. What is the wave number k? Now, this is also simple because k is equal to the square root of kx squared plus ky squared plus kz squared. So this is equal to square root of 0 plus beta over square root 2 squared plus beta over square root 2 squared, which is equal to beta. Alright, so that is also simple. Okay. This is beta squared divided by 2, this is beta squared divided by 2, so add up is equal to beta squared. Square root is beta. What is the unit vector? Okay, unit vector is equal to this divided by magnitude. Alright, so the unit vector k is equal to k divided by beta, which is equal to square root 2y plus 1 over square root 2z. Alright, because the unit vector is the vector divided by its own magnitude. Okay? Using the fact that E is perpendicular to K, determine the value of A. E is perpendicular to K, definitely. Electric field is perpendicular to K, electric field is perpendicular to H, magnetic field is perpendicular to K, and so on and so forth. So what does it mean? This one is actually give you a hint, alright? So what it means is that E dot K must be equal to 0. That's what they're trying to say. E dot K must be equal to 0. Alright, E dot K must be equal to 0 because it's perpendicular. Perpendicular means that the dot product is equal to 0. So now, what are we going to do? I get 1 over square root 2 AY plus Z plus a cosine something here dot 1 over square root 2y plus 1 over square root 2z must be equal to 0. Got that? E dot K must be equal to 0. Because the two vectors are perpendicular to each other, so E dot K must be equal to 0. Since this all is 0, 1, all this outside one don't care lah. All this outside one don't care. So the significant one is y dot y has a value, right? The dot product y dot y has value, so 1 over square root 2a. Y dot z 0. Okay, y dot z because they're perpendicular. Z dot y also 0. Z dot z has a value equal to 0. So a is equal to minus 1. So a is equal to minus 1. Okay, so determine the value of a. Alright, so a is equal to minus 1. Minus 1 here. Alright, so now we have the complete expressions for the instantaneous form for the electric field. And now it wants the instantaneous form of the magnetic field. Alright, once again, my E now is equal to 1 over square root 2. The polarization is there. And the phasor form Ej omega t E minus j beta square root 2 y plus z. This is my phasor form. H is equal to 1 over zeta k cross E. Alright. So remember there are few formula which you always use. K equal to omega square root of mu epsilon equal to 2 pi over lambda, and V times F times lambda equal to V, and also these two vector equations. Now, free space. Okay, free space. So zeta is equal to zeta naught is equal to 120 pi. Okay, no problem. That one, no problem. Okay, free space. Free space, zeta equal to zeta naught, 120 pi. What is K? Unit vector of K, just now we already determined, is 1 over square root of y plus 1 over square root of z. This is the unit vector of K that we have written out just now. Alright, cross 1 over square root 2 minus y plus z Ej omega t E minus j beta pi by square root 2 y plus z. You notice or not? These things are actually just like an appendix. You just keep on writing and writing, just an appendix. Got nothing to do with all this cross. Because all this magnitude after that you take out anyway. So got nothing to do with your all the vector operations. So I can just write 120 pi Ej omega t E minus j beta square root 2 y plus z. All this appendix right out first. Now, so many square root 2. Square root 2 times square root 2 becomes 2, right? So this is how. Do you know how to factorize this one? You bring the square root 2 out, right? Because 1 over square root 2y plus 1 over square root 2z is equal to 1 over square root 2 times y plus z. Right? So just bring the square root 2 up. And this square root 2 multiplied with this square root 2 is equal to 2. Okay, so I just put the 2 there. And then now starting to dot. Starting to cross, sorry. y cross minus y equal to 0. Y cross y is 0, right? The cross product. Y cross z is x. Z cross minus y is also x. Because z cross minus y is the same as y cross z. Alright, then z cross this one is okay. So this one becomes 2x. 2 and 2 cancel. There you go. This is your phasor form of H. So the instantaneous form of H basically become 1/20 pi x cosine omega t minus beta over square root 2 y plus z. And again, one last check, this one and this one must be the same. Alright? The so-called easy way actually is you don't have to copy all this phasor part down or the instantaneous form down, because the important thing when you cross this one is actually the vector, the two vector only. When you cross the two vector correctly, the rest are just there. Alright, any questions? Any questions, ladies and gentlemen? No questions? I hope that because you see, you know the format of the exam, right? Do you know the format? Oh, by the way, okay, CA2 first. Okay, CA2 we will be covering, of course, propagation in lossless media, propagation in lossy media, refractions and transmissions and transmission line. Okay, 4 topics. Okay, 4 topics. Now, so once again, there will be 4 questions. 1 question from each of these topics: propagation in lossless media, lossy media, transmission and refraction, and transmission line. Okay, so that one is quite okay. Now, then in the exams, there are 5 questions. 1, 2, 3, 4, 5 compulsory. Okay, each has 10 marks each. So 15 marks on these 5 questions compulsory. Okay, then we have 6, 7, 8, 9. 4 questions, you need to choose 2. 4, choose 2. Okay, choose 2. 25 marks each. So 50 marks here, 50 marks here. No, the 5 questions are small questions, compulsory. Okay, compulsory. And basically what we don't have, there is no proving Stokes theorem, proving whatever theorems anymore. So, relax. Okay, so normally the 5 questions are electric field and potential, magnetic field. Okay, then you have the electric field, magnetic field. Then you have the these propagations. Okay, propagations. Now the propagation, lossy and lossless. Lossless and lossy. Sometimes the refraction and transmission are included inside there also. All right. Sorry. No. I think all the propagations will be one questions, and there will be two approximately about transmission line kind of issues. Okay. This fine. Now, and this one is basically one electric field, one magnetic field, one propagation, and one transmission line. Alright, it's basically like this. Okay, so your propagations, whether it's lossless or lossy, definitely will have one small question here and one big question here. Alright, you can go along with it.
So do you want to choose the best two?
No, we don't choose the best two.
Everything I just
Why you write down? Why you spend your time to do the questions that you know best, right? Instead of write anything. Alright, gentlemen, ladies. Okay, once again, okay, we are not doing well, so we need to work harder. Okay. I do not want to have any class test today because I want you to have time to go to. If you want go to E40706 to check your scripts. Alright. If you don't want to check your script, it's okay also. Okay. So then I will see you next Tuesday. Okay. Don't be complacent, huh? Work harder. Sorry? So production will be long that later. We'll give you okay. We will actually also explain